Alright, so let's just get begin with the fluid dynamics. So before I start explaining you the fluid dynamics, I would first like to begin with a simple thing that is called as the fluids. What exactly is the meaning of the fluids and what exactly is the fluid? See, in a very simplest form, I would like to describe to you, fluid is basically the study of the motion of the substance, whether it's a liquid or the gas, and with respect to the forces that may could be the gravitational force, they could may be some external forces also. All right, so fluid is the study of motion of a substance, liquids and gases under the forces. Whenever the word fluid comes, most of the people they only think about the liquid stuff, like simply speaking the flow of the liquid, and yes, it has got some viscosity so that it's traveling a little bit slow. It's kind of a water which is having some splashes, white water foam, stuff like that. But it's not something like that. It is limited to the domain of the liquids. It has got another branch that is called as the aerodynamics study, which is means the utilization of the fluids in terms of the gases, because gas in itself is a fluid. Let's take this discussion to a little bit broader. Well, no doubt, our course is mainly focused on the visual effects industries. That's why we are understanding the fluid dynamics principle with respect to the Autodesk Maya software. But I would like to explain the broader and the bigger category of the fluids, that its propagation is not limited to the domain of the visual effects industry. It has extended its branches in the aerospace or aeronautical engineering. Think of the fact that while we create the model of the rocket, or the you can say the topology of the rocket, or you may could say the physical design or the structure of the rocket is completely aerodynamically constructed. Since it travels with a supersonic speed or with a very high speed, it has to resist itself against the motion of the air. So its blades, or you may could say the wings, are designed in such a way so that the flow of the wind should be completely aerodynamic. Alright, so all such principles are very very important when it comes to the fluid dynamics, and that branch of the fluid is very sophisticated, which is called as a CFD, that stands for the computational fluid dynamics, which is, I could say, that one of the most complex study of the fluid in terms of the engineering purpose, calculating scientific results. For example, you may be able to calculate the model of weather, ocean currents, study the hurricanes, calculating the vortex fields of the tornadoes, and you may could say heat and ventilations, the flow of the air through the tunnels, air conditioning, utilization of the CFD, which is computational fluid dynamics, inside the petrochemical industry, stuff like that. All right, so that's the another branch of the fluid, which is very you can say complex and sophisticated, and that's why the visual effect industries doesn't require that much kind of the calculation, because they are very computationally expensive. So what we have done is that the softwares, you could say the apps like Autodesk Maya, Houdini, FumeFX, things like that, they have created some intelligent solvers, which you may could say that the capable enough codes of the computer programming, and they do have the algorithms which are based upon the real world of the physics, and they are far enough capable to mimic the behavior of the fluids. So the fluids inside the visual effects industries are fair enough capable in calculating the motion of the smoke, liquid, you could say fire, explosions, stuff like that. All right, so our course is mainly focuses upon the study of the Maya fluids, the fundamentals of the Maya fluids. We would like to create things from the very much scratch, and we will be focusing much upon the capabilities of the Maya fluids. But no doubt, apart from the technicalities of the Maya fluids, one can also harness this course and the modules of this course with respect to the artistic and aesthetical knowledge. It's not required that you need to learn the Maya. The principles of the fluid dynamics could be applied to the softwares like Houdini and the FumeFX as well, or at least they would really help you in developing the more sophisticated artistic workflows, or you may could also strengthen your artistic knowledge. All right, so let's go ahead, and we'd like to talk about more on the Maya fluids. So Maya fluids dynamically simulates the motion of fluids which are based upon the laws of real world physics, and of course it has got its native fluid solver, which is based upon the Navier-Stokes equations. So I would like to talk about more upon the Navier-Stokes equations, because the Navier-Stokes equations are one of the most famous equations. There were two great scientists in our history. They studied the fluids based upon the Newton's second law. And the most important thing inside the Navier-Stokes equations is the vector field, or I could say that the vector field of the velocity inside the flow of the substance. All right, that's where the Navier-Stokes equation focuses upon. Now we would like to talk about more upon the Maya fluids. So Maya fluids are powerful enough to mimic the behavior of real world fluids. So I'm saying the word is called as a mimic. Why it's not like that? It's totally based upon the realistic laws of the fluid dynamics. Well, the thing is that in the visual effect industries, we do not require such kind of complex, or you could say computationally expensive calculations. So what we have done is that we have just tried to create the fluids in such a way that it is close to the realism, and not even close to the realism, it has extended its functionality more than the realism. Think about the effect where you could simulate the behavior of the genie smoke. So that's totally a magical smoke, and that is far beyond the scope of the real world physics. I mean, you just cannot create stuff like that. So there are many other things in which you could say the fantasy kind of the effects or magical effects, which is obviously not possible inside the real world, so that we have interpreted it, or we have created inside the movies with stunning visual effects. So that's where the software fluids excel itself. All right, and the good thing is that the solver, of course I'm talking about here, is the Maya's Autodesk Maya fluid solver, which is also uses the Navier-Stokes equations to compute the fluids with respect to each time step. So that means that if you're playing the timeline, you're scrubbing the timeline of your Autodesk Maya software, definitely the change is happening on the viewport. So that means that the calculation is taking place at every frame, at every step, and Maya is far enough capable in utilizing the complex Navier-Stokes equations. So that means Maya fluids are really very sophisticated. They are written with a very complex codes, that is the computer science engineering, and we have provided with the most, you could say, successful codes of the engineering, which are far enough capable in calculating the motion of the fluids. All right, and Maya fluids are useful in creating stunning visual effects, like we can able to create or simulate the fire. We could able to simulate the realistic smoke, be it a thick smoke, be it a wispy smoke. We could also able to create stuff like explosions, realistic dust, and just to name a few. Alright, so the thing is that the fluid has been adapted inside the visual effect industry, and the extension of the fluid is at a very greater extent. Nowadays, most of the Hollywood movies do include the inclusion of the fluids in their visual effects, be it the effect of, you could say, Superman coming from the sun, or emitting the heat waves from the eyes, be it Iron Man pumping or igniting its heavy, you can say, mechanical suit. And there are other stuff like the power that just simulates from the hammer of the Thor, that could able to damage any piece of the rock, or it could able to break the surface of the earth into two pieces. So all such kind of effects are very very important, and we could able to create them with the help of the softwares. All right, and that's just all about this clip. So we'd like to take a pause over here, and we'd like to move to the next clip, where we would like to further continue with our topics, and we'd like to get into the components of the Maya fluids.